Hello, here we're going to work out the moment of inertia of a ring. So it's not a disc, this is an actual ring. So if I've drawn that sort of slightly side on, but it is actually a ring rather than a disc. We're going to have an axis of rotation which is going straight through the middle. So it's sort of spinning round, like you're throwing it like a frisbee, that sort of thing. So let's get our formula for moment of inertia down, what we're trying to work out. So we're wanting to sum up a whole load of bits. We're splitting this ring into bits so we can add up all of the bits because we know that each bit has a moment of inertia which is m times r squared, where r is the distance from the axis of rotation. So how are we going to split up this ring into bits then? Everything's at the same distance here. If we got a radius r, capital R, then, well, that isn't changing for all of the bits that are in this ring. This r squared at the end is going to be a capital R squared. I mean, that's what we're going to have. If we're going to split each one of these little bits up, then we can say, let's think, well, these are going all the way round in a 2 pi's worth of angle here. We can integrate around the whole circle of the ring. So if the mass of the whole ring is m, so that's the mass of the whole ring, then our the mass of the little bit that we've got here, because this is going to be over an angle d theta. Let's vary this by theta all the way around. This isn't like when we were doing the uniform rod where it was r that was changing. We were changing the distance from the axis of rotation. Here we're not changing the distance from the axis of rotation. We can just think of this as lots of individual bits all the way around, all at the same distance from the axis of rotation. All of these individual masses all the way around. So if m is the mass of the whole ring, then our little m, our mi, is going to be d theta over 2 pi, because that's the fraction of the circumference that we've got of the ring, multiplied by big M. That's the fraction of the mass of the whole ring. So that's what we're going to stick into our integral. Our integral, we're now integrating over theta. So the r squared, as I've said, the lowercase r squared, that is just now a capital R all squared. And then we've got mi is m d theta over 2 pi. And we're going to be integrating that from 0 to 2 pi, because that's what theta is varying through, wherever we start 0 angle being, and it doesn't matter where we put it. I mean, this is all symmetrical going around. So, but we are going to integrate from 0 to 2 pi. Well, there's no thetas in this, so we're just going to get 1 theta dropping out at the other end. So we've got a r squared m over 2 pi. They're all constants. The integral is just the theta, which is going from 0 to 2 pi. So that part of the integral, the bit that's changing, is just going to give us a 2 pi, which will cancel with a 2 pi that we've already got in the constants. So we're going to end up with a moment of inertia, which is just mr squared. So yeah, it's quite an easy one, but it's that change from looking at the thing that is varying on this, or how we're going to add the bits up, how we're going to break our shape, in this case a ring, up into little bits. So when we had the rod, then we were breaking it up lengthwise along the rod, and that was changing our r, because the distance of each point from the axis of rotation was changing. Here the distance from the axis of rotation is not changing, but we're going to be dividing it up by theta. It's that part of it that's going to be changing all the way around. So it's another simple one to do, really, the ring about a central axis. Of course, if you were going to move the axis of rotation, then it changes things considerably. It's a lot more difficult then to work out exactly, because then we have got the radius changing. We have got that distance from the axis of rotation is going to be changing. So the radius of the ring obviously doesn't change, but the distance of each point from an off-center axis of rotation would be changing, and then we're getting into very complicated comparatively analysis on this. But yeah, when it's just going through the middle, it's fairly trivial.